Hello, welcome, parental learners. Today we will be exploring something a bit different, the Titanic dataset. It's interestingly and widely used in terms of data science when we get to learn things, but let's first give you a little bit of context about the event that happened in Titanic and how the dataset actually might be interesting to look at different things from a random forest perspective. Before we dive into the tutorial, let's take some moment to understand the context. So, the RMS Titanic was a British luxury passenger liner that sank in the North Atlantic Ocean on April 15, 1912. After striking an iceberg during its maiden voyage from Southampton to New York City, more than 1,500 out of 2,224 passengers and crew members aboard the ship lost their lives in the disaster, and it's become one of the deadliest peacetime maritime disasters in history. The Titanic dataset we are working with today contains passengers' information from this ill-fated voyage. One of the reasons that makes this data so unique is the amount of fields that we can explore. So the first field that we have is the passenger ID, which corresponds to a unique identifier for each passenger. We have survived, whether the passenger survived or not, which would be 1, 0. Then we have P class, which is the passenger class. The name of the passenger, you can do that. Then we have sex. Then we have age. The number of siblings and spouses aboard the Titanic. Parch variable, which is number of parents and children aboard the Titanic. The ticket number. The fare, that's the amount of money spent on the ticket. The cabin number. And whether they embarked in Cherbourg, Queenstown, or Southampton. So let's start by importing the usual models that we require. Pandas, Scikit-learn, and we'll use the Scikit-learn model selection framework, get the train test split, and from Scikit-learn we'll import the tree. We'll import also the library Scikit-learn metrics, and from that we'll get the accuracy score. The usual libraries that are being used to use. Now, as to get our data, we're going to use the pd-read function, and we'll actually be using the CSV file that I've got. The link just below on GitHub. So you can just download the titanic.csv file that I've made available for you. And once you have the data, you can do print data.isNull. What you're trying to do is remove all of the no data values that exist within different fields. In data, you're going to select the field age, followed by a dot, fill NA. So basically, fill none available. Data age, and we will be using the median so that there's a median age that likely those that have NA values, not available values, are identified, and in place equals true. So it selects and simply integrates that data set into that field. So then we have embarked. Embarked will do a bit different. We will just say that it is a 0 if data embarked finds no value. Again, in place, we'll consider true. And for cabin, that we're not being using too much, we'll just do a data drop. So data.drop, cabin, and axis equal 1. We're now ready to convert the categorical variables into numerical form. And we'll do that for sex and embarked. For sex, we will go and simply will male 0 and female 1. So 0 for male and female 1. For embarked, we will do 3 codings in the map function. So we'll use S, C, Q, 0, 1, 2, depending on the port of embarking. Then we'll add to drop features that we will be using the decision tree, such as name, ticket, and passenger ID. Split our data into X and Y. We've done that before using the training and test data sets. And when we do that, we should remember that we are considering the drop of survived for X, and Y data will be survived. And we will use X train, X test, Y train, and Y test for train test split on the XY test. 0.2 and random state 42. We're now ready to create our decision tree model. Model equals to tree, decision tree classifier, and we are going to fit the model. To do so, we'll do model fit, X, train, Y, train. This allows us now to do some prediction of survival of passengers in the test set. Y prediction will be equals to model predict for X test. So Y predict will be model.predict X test, and we can print the model accuracy to give us the result, and we'll use the accuracy score, the Y test and Y prediction.